Okay, this is going to be basic trig. We're going to using trig to find side lengths. Okay, you're going to need pencil, paper, and a calculator. I want you to take notes on this, write down everything that I do, and you'll be able to back up and if things go too fast. In the upper right hand corner of each of these pages, I am placing the trig ratios. Okay, so you can see them on each one. It is a good idea whenever you're using these to write them down. I still do. Okay, well, let's get started. Okay, let's say you have a right triangle and you know that this angle is, say, 34 degrees, and you know a side 7, and I want to know these two sides. Okay, well, you have to ask yourself, well, what do I have? What do I want to find? Let's find x first. Okay, we are going to find x first, which means this is the opposite side, and we've got the adjacent side. Well, which of these, but not the hypotenuse, which of these does not use the hypotenuse? Tangent, okay? So you're going to use a tangent, so write down the tangent ratio. The tangent of theta is opposite over adjacent, okay? Now, what is your angle? Your angle is 34 degrees, so let's write tangent of 34 degrees equals, now what is my opposite side? 7 over my adjacent, which is x. Now, go in and do the tangent of 34 degrees. You should have already watched the video that shows you how to do this, so I expect you to be able to. So the tangent of 34 degrees out to 4 decimal places, 0.6745. 0.6745, and that equals 7 over x. Now, here, to solve for x, you would cross multiply and then divide. But pretty much what happens is if x is in the numerator or the denominator here, and the answer is over there, then you can just swap them. X equals 7 over 0.6745. So x equals 7 divided by 0.6745. 7 divided by 0.6745 equals, so 10.4. We're going to round it to 10.4. Okay, make sure you got that written down. Now, we know this is 10.4. We want to find y. Well, here's the thing. We don't want to use what we just calculated to find this, because this is an approximation, which means this one's going to be even further off, okay? So you're still going to use this side and this side, opposite and hypotenuse, which will be sine, okay? So let's write down the sine of theta equals opposite over hypotenuse. Go ahead and write that down. Now your angle is 34 degrees, so the sine of 34 degrees equals my opposite, which is 7, over my adjacent, which is y. I'm going to go ahead and swap them now. Y equals 7 over sine 34. Okay, so y equals 7 over, what is the sine of 34 degrees? 0.5592. 0.5592. So do 7 divided by 0.5592. 7 divided by 0.5592 equals 1. Yep, I think it's 1.8, but let me make sure. 7, no, it's not. 0.5592 equals, there we go, 12.5. I don't know why I got that other number. Y equals 12.5. That makes more sense. Okay, so we found that y is 12.5. Okay, let's do one more. Make sure you got all this copied down. Do one more, and then I'm gonna have you do a couple of problems. Okay, here, this time I'm gonna I'm going to give you the hypotenuse. Let's make it 8. And I'm going to make this a 30-degree angle, okay? And this, of course, is a right angle. Well, real quick, if this is 30, then what angle is this? Anybody? It's 60. Now, we're not going to use that here, but I just want you to know that. So you're going to find y and x. Well, let's choose first. We've got the hypotenuse. Do we want to do the opposite or adjacent? Well, because x is before y, let's do that. And that's the adjacent side over the hypotenuse would be cosine. Okay, so we're using cosine of theta equals adjacent over hypotenuse. And so the cosine of 30 degrees is the adjacent, which is x, over 8. So your answer is going to be 8 times the cosine of 30 degrees. That's going to be x. So let's find what x equals. 30's cosine is 0.866. So 8 times 0.866. So 8 times 0.866, that's 6.9. So your y is 6.9. Now to find the other side, it's going to be opposite over hypotenuse, which is the sine function. Now, let me make sure I've got this. Okay, so we're going to use sine. So let's do it. Sine of theta equals opposite over hypotenuse. So the sine of 30 degrees equals y over 8. So 8 times the sine of 30 equals y. Now when you punch that in, you get 8 times, well, the sine of 30 is 0.5 equals y, so y equals 4. This would be 4. All right? That's how these problems work, to find the side length. So now I'm going to give you 2 problems. We're going to make this a 40-degree angle, and here's your right angle. And let's make this a 2, and I want you to solve for the hypotenuse, okay? Then in this one, let's make this a, not that. Let's make this a 25-degree angle. And you've got the hypotenuse, which is 9, and you're going to solve for this. Actually, let's make it a different variable. Solve for r. All right, go ahead and do those 2 and answer the questions that go with this right here, and then I will show you how to do them. Okay, you should have answered them. Hopefully you actually wrote down your work and you got something close to correct. Let's look at the first one. Your theta is 40 degrees. You're working with the opposite and the hypotenuse, which is going to be your sine function, okay? So, write down what you're doing. Sine of theta is opposite over hypotenuse. Therefore, the sine of 40 is 2 over x. We get x is in the denominator there, so swap those. X equals 2 over the sine of 40. So x equals 2 over 0.6428. 0.6428. Therefore, x equals 2 divided by 0.6428 is 3.1. Okay. That's that one. Now let's do the other. 9 over r, or 9 and r, you got the hypotenuse is 9, and r is your side that we want to solve for. Well, let's take a look at it. We've got the 9, the r, our theta is 25. In relation to theta, keep in mind that this is a right angle here. In relation to theta, we've got the opposite and the hypotenuse. Well, that's easy enough. So we're going to do sine one more time, okay? So let's go ahead and grab a pen. Make sure you know that's right angle. So we're going to do sine again. Sine of theta equals opposite over hypotenuse. So the sine of 25 equals opposite, which is r, over 9. So 9 sine of 25 equals r. And that's going to be 9 times 0.4226 equals r. Therefore, r equals 0.4226 times 9 is 3.8. 3.8. So r is 3.8. Okay, that's using trig to find side lengths. Now, let's turn it around and look at finding an angle, because it's written a little bit differently when you do this, okay? Well, there are different ways to write it. Let's say you know that this is a right triangle, and you know that you've got sides. Let's go with what we know, 3, 4, 5, okay? And I want to find what theta is, okay? Well, let's choose a ratio. You can use either the ratio, but either way you want to get theta. And what you would, let's do tangent, okay? So the tangent of theta is opposite over adjacent. Well, my opposite side is 3, and my adjacent side is 4, okay? So the tangent of theta is going to be 3 over 4. Now, I want to solve for theta. This is what you do. You write the arctangent of 3/4 equals theta. Right now, tangent of theta equals 3/4. To switch it around, to solve for the angle, you would write that the arctangent of 3/4 equals theta. Then you go into your calculator and do, the second tangent, and 3/4 is 0.75. On the iPhone, I would write 0.75 and second tangent, and it would give me 36.9 degrees. Another way of writing that, if you just want to keep it here, like this, you can, and just understand that you've got to, once you have that the tangent of theta is 0.75, you write 0.75 and then arctangent button, and it'll give you the answer. It's kind of what you're comfortable with. But to show you that this actually works, let's do a different ratio. Let's do the cosine ratio. So the cosine of theta is going to equal adjacent over hypotenuse, which is 4/5, which is 0.8. So the arc cosine of 0.8 equals theta. Well, let's go in our calculator and write 0.8 and then arc cosine. And what do you know? It's still 36.9 degrees. Okay. Let's do one more to show you that this works. Okay. And again, there. We're going to go for this angle. We're going to call it theta still. But remember, you can call it alpha or you can call it George for all you care. But either way, same principles apply. Okay, you've got that one. And let's choose a side that you know. Let's say you know, or the two sides you know, or three sides. 5, 12, 13, another Pythagorean triple, okay? Well, we want to solve for theta. Let's use cosine this time, which means we're going to use the adjacent and the hypotenuse. Okay, so we're going to do the cosine of theta, which is adjacent over hypotenuse. And so the cosine of theta is 5/13. So we're going to do the arc cosine of 5/13 equals theta. So I'm going to do 5 divided by 13 on my calculator. Gives me 0.384, well, 0.38. So let's do the arc cosine of 0.38 equals theta. So 0.38, and then do the arc cosine, and you get 67.7 degrees. 67.7 degrees. That equals theta. All right. Now, let's do these problems. I'm going to give you a couple, and I want you to do them. Again, right triangles, okay? Here we're going to solve for this theta. Here we're going to solve for this theta. In this triangle, 7, 24, 25, and you can do it either way you want to. You can use any of these that you wish. And for this triangle, this one, let's see, 6, 3, and 3√3. Okay, I want you to take the time, go ahead and do both of them, and then come back, put your answers in, and then come back, and I will show you how they work. Okay, I should have gotten both of them done. Okay, this first, let's do opposite over adjacent. Let's do tangent. So the tangent of theta is opposite over adjacent. So the arc tangent of 24/7 equals theta. So I'm going to do 24 divided by 7 and do the arc tangent of that. Gives me 73.7 degrees. Okay. Now this one, the one in the bottom right, let's mix it up because I don't like dealing with radicals. Let's do opposite over hypotenuse, which is sine. Sine of theta equals 3/6. Therefore, we're working with the arc sine of 3/6 reduces to 1/2. Let's put 1/2 equals theta. So let's plug that into the calculator. 1/2, which is 0.5, and then do the arc sine, and you get 30 degrees. 30 equals theta. Okay. Now, we're sitting here doing all this. How does any of this matter? Well, there are all sorts of things, okay? All sorts of applications. What if you have you got a set of stairs? Oh God, that's just horrible. You've got a set of stairs, or you've got a platform, and you need to build something up to it, like a handicap access. And you know that this angle has to be just a certain amount. It can't be more than like 10 degrees, or the person's going to fall backwards. And you know this is 5 feet high, okay? So let's say at most this is going to be 10 degrees. Well, that will tell you that you're going to have to build out a certain distance. And how would you find that? Well, assume this is your right angle, and then you would do opposite over adjacent. So tangent, the tangent of 10 degrees is going to equal 5 over x. Swap it and you get x equals 5 over tangent of 10. Do that on your calculator, however you can do it. Tangent of 10 degrees is 0.1763, so it's 5 over 0.1763. Remember, trig ratios go out to 4 decimal places. So 5 divided by that tells you that you would have to build it out 28.4 feet. This would have to be 28.4 feet. And then you could also use trig, or you could use Pythagorean theorem to calculate how long the ramp would actually be, okay? That is just one little application of trig in the real world, and it is used, okay? I hope you got something out of this. I hope you retained it, and I hope you kept notes. If you didn't, go through the video again and keep notes on this, because you will forget how to do some of this, and I don't want to spend too much time on it. All right? Thank you very much.